Good. Let's start. So today we will talk about heritage building. So this is another relatively new and not completely established field. Okay, so it's a field which is still under exploration. So, but it's a very important field. I think there are a lot of opportunities again in this field for you as for a job opportunity. I don't know if you are interested in heritage, like restoration, renovation, but for Turkey, it is a very important field because we have a lot of heritage, okay, and that heritage needs to be managed. Now, this is the important word, managed. But normally, what they do is, in terms of heritage buildings, what they do is they basically intervene to what's happening. Basically, buildings decay, they get worn down, or they are damaged, and you basically repair it, okay? And so far, the conservation efforts were mostly repair and done, okay? But now what we know is that if it is a heritage building, we should be also looking back in time, like what has happened in that building, what kind of changes it has gone through, okay? And we need to also present it to people, okay? So, because there will be visitors, cultural visitors, there will be public interest in it, because we will mostly be spending the money of public too, okay? So most of these buildings are public buildings, and we use the money of the state, which is people's money. Okay, so it means that we should give something back to the people. Tell its story, for instance, where it's coming from, what has been done with that building in the last 500 years, 1,000 years. Okay, so this means that we have a very large set of data and information. Okay, like we have the history of the building. We have events that has happened in the building. We have documents about the building. We have photographs. We have plans, drawings. We have, of course, depending on the age. We have, let's say, analysis, many different analysis. And another thing is that some of these buildings are actually continuously in flow or motion, like Hagia Sophia, for instance. Okay, Hagia Sophia, we see many people visiting it. The building is vibrating, so we should be monitoring, for instance, cracks, the humidity, all kinds of data. So this is another thing. When the heritage building is rich in terms of its, let's say, value or features or history, we should be keeping a look on it so that we know that the building is performing and not being in a state of decay. Okay, so that's another thing. So all this means that past data, past history, the stories about the building, the actual building itself as an object, the restoration, renovation efforts, and presentation of all these, and also monitoring of the building itself, means that we capture a lot of data and information. It's actually, when you think of it, it's even worse than new building. Because with new building, the data and information we are dealing with is relatively limited. It depends on the number of people involved, etc., and then we capture the design process. That's all we are interested in. But with an old building, the data is, to be honest, it's unlimited. I mean, you can fill up gigabytes of data regarding an old building. Okay, you have thousands of photos. You have many data points analysis. So heritage BIM is all about managing that, but with the mindset of BIM. So that's the idea. Okay, so we'll talk about that today. Okay, we will talk about what is the core challenge, why modern BIM and heritage BIM are so different in many ways. Reality capture, scan to BIM workflow, and managing the data. Okay, so that's what we'll talk about. Yeah, the new buildings, BIM, it's relatively standardized as you have seen so far. It's relatively straightforward. We know what to do, and it's easy. But we have to use that to document, analyze, and conserve existing irregular historic structures. Irregular is the keyword. Because with a new building, you design perfect walls, unless you are Frank Gehry. I mean, you design perfect walls, okay, and they are regular, they have dimensions are right, and you expect the building to be representing the drawing, okay, like when it's finished. It should be, if it's a high quality construction, it should be more or less, you know, it should fit to the drawings. But with historic buildings, they are irregular because the walls get crooked, the construction techniques are different, you know, they don't have such, let's say, technology that we have today. Surveying is, again, limited, so they are weird, okay? When they are weird, it's not easy. So how can we expand our understanding of BIM into the cultural heritage and existing architecture? So this is an important part. And how heritage BIM adapts three-dimensional parametric modeling to handle the irregular non-standard forms and the unique craftsmanship, because there will be all kinds of things around us. So we will talk about scan to BIM workflow, okay, which I also talk about in the tutorial, but I'm not expecting you to test it because you need drones, you need many photographs, etc. So we don't have that, and I didn't want to bother you with that. But it's something. Maybe I will start a course on heritage BIM, and then we can play with it in the next years. Okay. And again, heritage BIM serves as a central multidisciplinary database, and we want to combine geometric data, okay? Even though if it's irregular, it's geometric data, then we combine it with historic records so that we have structural assessments, preventive maintenance, and conservation planning. Preventive maintenance, this is another thing, right? What do we expect to happen to the building? So how can we deal with it? So that's the idea, okay? So basically, we have two-dimensional archives, like we have drawings, we have 3D scans, we use raw laser data like point cloud. We basically turn it into predefined three-dimensional library objects. Okay, so we basically create a parametric library, and then we add materials, construction methods, historic significance, those kind of, let's say, things into the model. Okay, so let's start. Now, as you know, standard BIM methodology has these digital representation capabilities, so we use it to document, conserve, and manage historic structures. So that's the idea. So, what do we need to do with a historic building? We need to document, okay? We need to capture what is there. Also, we need to find out information about that. Like, for instance, for Faculty of Architecture building, this is a relatively old building now, 60 years old, okay? So we can go and find the drawings. We can go and scan the building, okay? Create a documentation out of the existing building, okay? Then we can figure out what we need to do to conserve its state, or current state, and how can we manage the building so that in the future it will last longer. Okay, so that's the idea. So, with standard BIM, we have the digital representation of the physical and functional characteristics of the buildings, right? So we basically define the size of elements, we mention the materials, we basically represent the building digitally in a way that we are following a standard format, right? And it is used for decision making. BIM is all about decision making, right? So in the construction process or prior to construction process. And BIM is normally for new construction. Heritage BIM is for existing buildings, okay? Historic buildings. Management, refurbishment, preservation, okay? And we use reality capture techniques. So this is what we call reality capture. You did your summer practice last summer, right? Did you use the laser scanner? So you know what it is like, right? So it's a device like it scans, and then you receive millions of data points, millions of measurements from the 3D environment. So that's the laser scanner. And by itself, it's a great tool, okay? But we will talk about it in the next slides. But at the end, it's just point cloud, okay? So what are we going to do with it? Heritage BIM is all about finding a good use for that data. Okay, so that's what it is. So basically, we digitize the complex geometry, unique geometry of the heritage, and we turn it into something that's usable. Okay. So yeah, with BIM, we have standard libraries, we have perfect geometry, we basically design slowly. Okay. We start from conception to go to the construction. We use standard parts, okay? But with Heritage BIM, we use laser scanning when we basically scan an existing building. Existing building is like that. It's crooked, it's damaged, it's not perfect, okay? And there are irregularities. There's an arch. It's not a perfect arch, okay? We need to reverse engineer. What is inside? How does it work? So we need to figure out what's going on, okay? And of course, we need to map all these things so that they are interlinked, okay? So that's custom mapping. So normally, we use, like what they do with the laser scanning, for instance, Kemal Abi, okay, or Filiz Hoca. So they do laser scanning, okay? And with this laser scanning, they create two-dimensional drawings. That's all they can do now, okay? This is what we are trying to avoid, right? So with BIM, we don't want 2D drawings. They are useful, they are good, but it's not what we want. They basically create a laser scan, then they take slices. So like they take a slice at 1.2 meters to draw a plan. They take a slice to draw an elevation, okay? Or, in the best case, they use that scan to create a 3D view, okay, in 3D, a 3D model, okay? That's what they do. But 3D model is only an empty shell, okay? It's not something that is enriched like we do in BIM. So, they capture surface geometry without underlying data. So you capture the surface, but you don't know what is behind that skin. Okay, so you create a 3D skin out of points, but you don't know what's behind. You don't care about it in traditional historic documentation. This is not what we want. With Heritage BIM, we create smart parametric objects, digital elements. They're defined and altered by specific parameters and behavior rules, which is, you know, this is the same thing with BIM, right? So we create a wall, we create a window, and they are parametric. They work as they should, okay? And when you think of it, the model is no longer a drawing, okay? The model is a computable database, which we can use to do structural analysis, energy performance simulations. There are all kinds of things that we can do, okay? Yeah, so 2D, we can do digital photogrammetry. By the way, I have to tell you something. You know what Kemal Abi uses now, this laser scanning. Okay? When I was a student like you, he was using something called photogrammetry. And photogrammetry device, I don't know if he ever showed you, but I believe he still has it. But it is a camera. I'm not going to put my coffee there. It's a camera, okay, with like two lenses. And it takes a stereo photo on the same film, which is very weird. When I was a student, I remember we went to Fethiye with Kemal Abi and the whole class in the first year. winter. And then he took photogrammetric photos of a theater, of the theater in Fethiye. And what he did was, he puts them on a special device. It's still in his room. And with this, it's like a microscope, and he can basically match two cameras into a single drawing, orthographic drawing, perfect orthographic drawing. So that's what he does. Okay. So and these two-dimensional drawings were coming out of that. Okay. And today we can do the points. Okay. But with Heritage BIM, we can create meshes first. Okay. Then we convert these meshes to parametric objects. So that's the idea. But in the past, it was only two-dimensional. Okay, so this is what we are trying to avoid. Okay, so basically, the Heritage BIM model in this case becomes a central collaborative repository, which means that with the Heritage with the Heritage Conservation Project, we have many partners. Okay, we have many stakeholders. We have engineers, again, we have historians, we have architects, we have restoration professionals, okay, we have many different people. We have the public, the Ministry of Culture, we have many people. We have the municipality, we have the general public, they are all involved. So we basically create a spatial model, like the geometry, but we relate it to other pieces of data, like the history.
So it is also a federated model.
It's a federated model, exactly, but now we are not federating the structural engineer, mechanical engineer, we are federating, for instance, the oral story, oral history, okay? Like people are telling their experience about the space, for instance, the video recordings, the sound recordings, the posters from events happened in that location. Let's say, drawings. There are all kinds of different data. So the data, we still have data, but it's different. Okay, it's about the history in this case. So we basically have a single consistent repository, because this is a big problem in conservation. You have files and files of documents, but they're all spread. With Heritage BIM, for instance, you can relate one file, like let's say we take a picture now in this room, okay? 50 years later, there's a model of this room, and our picture is connected to this space, okay? Or there is a repair that's done on a wall, okay? That we have the, let's say, repair process photos, we have the, let's say, in that case, well, bills, the people who worked in that repair, they're all listed. We have documents, we relate to that wall. So the object itself becomes the connection point for different data pieces, okay? So in the future. In that regard, it's amazing, because when you think of it, you have files and files and files, folders and folders and folders of data, but they are all coming together in spaces with objects, okay? So for the future. So basically, instead of just having a 3D model, we have a model that has embedded semantic data, like the historic construction phases, archival documents, material makeup, previous restoration techniques, whatever has been done in that model, okay? So basically, if you select an architectural element, like the wall, as I mentioned, okay, you can figure out its historic significance. Like you could say that this is a renewed wall, this is the original wall, this is the only original wall in this building. Everything else is replaced. Its current state of decay, like there is a crack on this wall, and we put a sensor on the wall, and we can immediately see how it works, okay? And its material properties, okay? So yeah, we have this central repository now, and we have smart objects, which are created over meshes that we create with these scans. And we have historian basically collects the data, history, the books, documents, etc. Structural engineer can now because it's a 3D object, it has all kinds of, let's say, material properties. Embedded structural engineering can also use it to make analysis and say that, well, we have to support it from here, we have to replace this, etc. And these all come together. In this case, we now have also a common data environment. But the thing is, we'll talk about that, but the common data environment with for Heritage BIM is not that standard. So there are many different Heritage BIM projects ongoing all around the world, and everyone is trying their own way of doing it. Okay, so there is no, because it's a very niche, new area. Okay, so people are programming their own, let's say, common data environments. Okay? And of course, we want to use it for long-term life cycle management, okay, of the buildings. And in this case, the Heritage BIM model can be used for preventive maintenance, energy efficiency retrofits, or if there is going to be a physical intervention, we can use the Heritage BIM for that. Okay? Also, the structural deformations, we can follow them, like what's happening in time. How do these pathologies change in time? This is what we do in the summer. In Italy, I run a summer school with some friends from Italy and Spain. And every summer we take one building and we focus on what's happening with that building, with the concrete, let's say structural concrete, and how it deforms in time. And then students, like last summer, Eleanor was there, students basically look into using that let's say observations and convert them into BIM model. And this is something that I also show in the tutorial. Okay? So it's useful because we can also use it for virtual tools. Okay? Now this is another thing. Because now we have internet, we don't have to rely on people coming and visiting in person. Okay? We can convert all our cultural heritage because it's environmentally better actually. Because the less people visit a building, the better it is because it's not going to be damaged. Okay? And the more you present the building in virtual reality, augmented reality, or all kinds of ways to do that, the better that people understand and they prefer not to go in person. Okay, so it's something very relevant. So, education, materials for general public. So general public needs to be fed. Okay, so this is what we want. So yeah, we basically scan, we basic data capture, we do diagnosis, we make predictive modeling out of that, we do intervention planning, we do maintenance tracking through the life cycle, and then we also do cultural dissemination. This is what we call with the virtual reality, with the 3D models, with the websites, there are all kinds of ways to do that. Okay? So the common data environment in that case basically turns that tangible geometry and intangible history into something that supports the survival of the building. That's the idea. Okay? So, but of course, the way we do Heritage BIM is challenging, okay? And we need to also train professionals, okay? Because when you think of the standard BIM libraries, they are standard. Okay, you cannot just put a regular window in an old building, old heritage building model. Okay, because it will not fit. So the standard BIM libraries lack the complex heterogeneous components. Okay, so which means that we need to create custom parametric families from scratch for heritage BIM. Okay, and another thing is that this irregular historic element is scanned. Okay, the common way of working in this field is that they use laser scanner, they use like millimetric scans, which are very accurate. But the problem is, if you scan like one wall in that detail, that wall will be gigabytes of data. Okay, so with a Revit model, one wall is like, I don't know, 10 kilobytes, 100 kilobytes, what is it? But with a Heritage BIM, if you want to insert it in your model like that, with all the concrete texture, the holes and everything, you will fail miserably. Okay, so it's not what we want. So we should basically simplify that model into a simple thing. Okay, maybe not 10 kilobytes or 100 kilobytes, maybe 500 kilobytes, but at least, you know, it is representing the reality in a way, okay? And at least it is still manageable. So in this case, we have to define the level of detail and level of information properly, okay, for each element, so that we don't have unnecessary modeling fatigue, you know, because otherwise it's going to be very difficult. If you want to model everything with high precision, everything, just it's going to be like gigabytes of data, your computer will crash, it's not going to do. Okay, so we have to find a trade-off. So, perfectly accurate, non-parametric laser scan mesh, highly parametric but very geometrically simplified. So we have to find the sweet spot. So where do we do it? Okay, how can we simplify it? So, the challenge. Standard BIM uses standard building components, but they are not useful for BIM. And of course, we are using the predefined constructive assumptions with standard buildings, but with built heritage, the old buildings, things are not that way. There is a heterogeneity of materials, construction techniques, irregularities. What does this mean? Like that old timber Turkish house, you can find all kinds of stuff in it. I'll tell you one story. They were doing a restoration work in my hometown, and one of the retired lecturers from our department here, he told me that he wanted to see, because he was seeing that there's a structural problem. The building was always leaning, okay, so there's something wrong. It was next to the river in my hometown, Amasya. So he said that he convinced, but he couldn't convince the authorities, okay? Like he was like, we have to dig, figure out what's going on at the foundation level. And of course, finally he convinced them. And when they dug, they figured out that the foundation was actually a pile of garbage. It was not a proper foundation at all. They just filled in whatever they could find. Teapots, seriously. Timber, teapots, and this is next to the river. It's like 150 years old. Okay, but it was in horrible state. And you cannot keep that foundation as it is, just because these people 150 years ago didn't have money, didn't have the resources, they did a bad job in the foundation. You cannot keep it for the sake of history. You need to replace it with a proper foundation, okay? So this is the intervention. Okay, so normally you would assume that it has a proper foundation, but with the historic buildings, the heritage buildings, you never know what's going to end up. You're going to end up. Okay, so you need to, in that case, represent them. Okay, so this means that, like when you scan, like you receive any data about the, let's say there's a timber beam there, there's this, let's say, timber post, there's this, let's say, adobe brick wall, okay? Someone should be piece by piece modeling it, okay? So that's the idea. Yeah, modern buildings are straight and nice. Heritage buildings are complex. We need to piece by piece deconstruct them and simplify, okay? And of course, for each unique element, we need to create custom parametric family, okay? And this is the difficult thing with heritage BIM. With regular BIM, you know, you just simply define dimensions, etc. With heritage BIM, you need to figure out how it's going to work, okay? So you don't have a Corinthian column, okay? Column head. So the Corinthian column head needs to be somehow turned into an object which is parametric. Sometimes this is the difficult part, but this is why this is a very, very important field. Sometimes, because we have some AI algorithms, but they don't really work correct. So we need to find ways to simplify this. People are still researching. So this is why I'm telling you, if you are interested in historic buildings, okay, this could be a field for you to continue and be relevant in terms of technology of the age, okay? And that is, for instance, creating that complex but parametric representation of the actual point cloud, okay? So that's the idea. So most BIM software have very simple, as you know, with Revit, right? We have very simple 3D geometry tools, and we sometimes use other software, okay? But we basically try to idealize things in that regard, okay? And it's difficult, okay? It's difficult, so we have to be figuring out. So this is the reality. What is it? Like, we don't want to put it that way, but it could be something like this, for instance. Okay, something in between. Middle, hybrid, ground. Okay, so because this is the actual building. And this is the actual wall. Point cloud gives us perfect image, okay? We cannot simply say there is a simple wall, because it erases the historic value. Okay, we don't want that. But we want to find a middle ground, because we cannot put it like this into the BIM. This is the middle ground. Okay, how do we find the hybrid middle ground? Okay, so yeah, with extreme geometric accuracy we cannot do that. Oversimplifying is also a problem. So we need to find the intended uses of the model. This is another thing. Like, the question is, what should be? Like, could it be just simple wall like that, or could it be like this, or something in between? Like, how do we define that? So we need to be able to define that. Level of information need here, you know, is important. We have to define it. Okay. So do we look for semantic richness? Okay. Do we want geometric accuracy, high fidelity, or we want parametric behavior? There are these three different use needs. Okay, so, and we have to be balancing all that. Okay. Sometimes maybe the semantic content is more important, so a simple representation is okay. But let's say it is Tutankhamun's, you know, grave, like tomb. Okay, right. So you need to, like, every little millimetric measurements needs to be somehow integrated. Okay. Now we can do native parametric modeling, and in that case, the tool you use is very important. Like, if you're using Revit, it has different skills. If you're using ArchiCAD, it has different skills. If you're using Bentley MicroStation, it has different skills in terms of modeling capabilities. So if you use a perfect tool for that, or optimum tool, and if the native tool fails, like, you know, if I ask you, like, how do we do that with Revit? Probably it's going to be very difficult, okay? Well, what do? We go to another tool, NURBS modeling tool. What is NURBS modeling tool that you can use? Rhino, right? You can use Rhino to model that wall and then bring it to Revit, okay? So which means that your laser scan feeds Rhino. Rhino is used for simplifying geometry. There are many algorithms that can simply create meshes out of point clouds. Then you can simplify those meshes, turn it into this blocky, this blocky, let's say, representation. This one has something like 200 faces instead of millions of points. 100 faces is okay. 200 faces is okay. Then you create that in Rhino, NURBS, and then you bring it to the big environment, okay, for heritage work. But the problem is, if you bring it there, you cannot edit it anymore. in Revit. Okay, so this is the issue. So it becomes a fixed element. But the question is, are you okay with that? Well, you might say that, well, I have the workflow, fixed, and I can just do that continuously, create all kinds of objects, bring them into Revit, and then I can put the wall, let's say, property into that object. It becomes a wall. I can put the material of that object there, and it just works. Yeah, why not? So yeah, because with the nature parametric modeling, you can only do a few things with the wall, okay? But with the NURBS modeling, you can do all kinds of things with the wall. Then you bring it to the model, but it's locked. That's the idea, okay? Now, let's talk about reality capture. Reality capture is, of course, why we can do this. Without reality capture, we wouldn't be able to talk about heritage BIM, okay? It's not new. I remember very well when I was a student in the US, in year 2003, I was at a conference and they were showing us how we could use laser scanner to capture the spaces, and they were working on how to convert that laser scan into a model. That was like 23 years ago. I don't know, you weren't born, 2003. Okay, yeah, 2003 they were doing that, and which means that we basically collect first the legacy data. We collect data about the building. We look into archival documents, like old drawings, blueprints, historic accounts. Okay, this is important because we want to figure out what happened so far. Okay, like we have this mosque. Okay, and we know that it was initially a temple. Roman temple. That Roman temple turned into a church. Then it was turned into a mosque. So then we have these, time milestones in the life of that. Okay. So the question is, what kind of interventions were made? How can we figure that out? Construction systems, materials, and level of development, level of information in that regard works even for that. Like we want to say that I want this to be represented in that way, okay? So yeah, we have all that, two-dimensional drawings, historic blueprints, manual measurements, ink paper, and you return them. Now, this is another thing. You can also use the old drawings to turn into a BIM model that represents how it was supposed to be built when it was first designed. Okay, so you can do that too. You can have many layers of BIM model elements. That's the idea. Okay. Of course, we use terrestrial laser scanning (TLS). Okay, because it gives us a millimeter level 3D model. We have point clouds. Okay, and that point cloud accurately maps the complex irregular surfaces on the building. Perfect. But the problem is with the laser scanning. The limitation is you need line of sight. So if you want to scan this room, especially this waffle slab, you want to be able to see every point inside that. So which means that you cannot have one laser scan from one room. Okay, we want to have 1, 2, 3, 4, 5, 6, 7, 8. Like this room needs at least 8 to be able to see everything. Even then, you won't be able to see everything. What, for instance? These pipes, you cannot see the top of these pipes because they just cannot work. Okay? So this is a problem, and also, of course, it's expensive. A laser scanner costs like, I don't know, 100,000 euros today, 300,000 euros. Okay? Millions of Turkish liras. Now, and you need not just a scanner, you need a very high capacity, high capable computer with very high-end graphics card, CPU, memory, etc. Storage space. And then, of course, you need time. And you need trained people. Okay, so it's very expensive. So what is the alternative? Yeah, this is how the laser scanner works, right? So laser scanner sends a laser beam, then it measures the distance. Remember I showed you my, do I have it here? I think I have it. Just wait. Yeah. This is a very simple laser scanner. Okay. See that? So it is like a laser pointer, but this is a laser one-point scanner. Because so it takes like now it measured 4.55 meters. Okay. So a laser scanner, the way it works is that it takes millions of measurements, 360. It turns around, takes millions of measurements with a device like that. Okay, this works with, there are two different technologies, time of flight, and what was the other one? I forgot. And the scanner works that way. Okay, so it basically, you can measure, with this one I can measure even that, 15 meters from here. Okay, so it takes like 100 meters long shooting of laser beams, and then millions of measurements captured into a single file. That file we call station. Okay, so every point where you take millions of measurements is a station. Okay, and you take like 5, 6, 10 stations, and then the computer matches these points with each other, relatively to each other. Then it places them in 3D space. Okay, then it confirms that they are perfect. And then this is how you end up with millions of points. Okay? What is the alternative? Photogrammetry. Particularly, today we call it digital photogrammetry. Okay? Structure from motion algorithm. This is this technology that we use. This is what I use. And the idea is that, well, with TLS, as we said, you know, you're taking measurements for a point, and it is there is this need of line of sight. It doesn't work great in that regard. But digital photogrammetry, you take many photos, okay, with different viewpoints, with different angles, okay, and then you basically. And another nice thing is that with digital photogrammetry, the photos that you take are high resolution, nice photos, which also capture the texture, the color, the actual, you know, the actual state of the building. And then it's used for material decay, cracking patterns, all states of the building, okay, in that case. And we use drones today. The drones are important because drone can fly over the building, and then you can take photos from points which you cannot access with the laser scanner. There is no way that you can raise the laser scanner and keep it stable enough to take laser scanning measurements from height. There are only LiDARs today. It's very similar to laser scanner, but not that precise, which you can connect to a drone. Okay, that's one way of doing it, but normally we cannot do that. So drones are very important, and you can reach areas which cannot be reached with laser scanners. Okay, so with the camera, you use the tripod and you use camera all around to take photos. With the laser scanner, with the drone, you take photos from top, and then you overlap images. Every image should be like 60%, 80% overlapped, okay? Which means that you're taking slightly different pictures of the same thing, okay? This was an exercise when I, in the past years in this class, but this year we're not going to do that. But it's fun, I have to tell you. Then these overlapping images are brought together with structure from motion algorithms. There are different tools for that, okay? There is Autodesk recap photo. We have reality capture, or reality scan from Unreal, the computer game company. And they give it for free. It used to cost. They used to charge for it, but now it's completely free. It was free for universities anyway, but now completely for everyone. Why do they do that? Because they need the scans of real-life objects for games, and they sell games, so they give it for free for people to be able to create beautiful games. Okay, so it is used for mostly for objects, but you can do that for buildings too. Okay, and then also there's Agisoft, Meta Shape. I'm not sure. I think it's Meta Shape, Agisoft Meta Shape. Cool. So that's a Russian software. That's another very good software. So with that, you create point cloud, and also you can create with that point cloud geometry. I show you how it works quickly in the tutorial with the first few minutes. Okay. Then there is this hybrid data collection. Now you can use laser scanning first on the ground to make sure that everything is perfect, they align, because laser scanning is precise. Then you use drones and photogrammetry, you combine that together. Okay? One of my students, she did her master's thesis on that. If you are interested, you can go and look at Ecem Kulübeci. Okay? So, yeah, we can basically, basic geometry measurement basically turn into deep diagnostic understanding of the health. Okay? So, the hybrid point cloud, hybrid BIM. Okay? TLS plus photogrammetry basically combines the best of both worlds. So it's a good idea to have both of them. Okay? And now how do we do? If you scan both with laser scanning and the digital photogrammetry, you end up with things that you don't want. Like trees, like vegetation, objects, people, cars. You don't want that. You have to filter them, clean them to isolate the building. Okay, and then you create polygonal surface meshing. Okay, triangulation, and then you create as a result photorealistic texture 3D reference model. Like point cloud has all kinds of things, but you want to get rid of them. This is a difficult thing also, because sometimes there will be trees that are really close to the building. You have to discuss with the owner. Sometimes you have to cut some branches of the trees. Okay, if they accept it, that's a good way of working. Okay, and then you clean and you mesh, and then you create a textured mesh reference, which is coming from the digital photogrammetry. Now, what is a scan to BIM workflow in that case? Basically, we take the reality capture data and then we convert it into parametric building information model. Okay, because the scans, the photogrammetry results, the point clouds, they don't have any semantic data. There are only billions of spatial coordinates. Okay, so scan to BIM means that we are basically bridging this gap so that we are creating computable object-oriented BIM elements. Okay, we do data acquisition like the scan. Then we do data processing like the scan is converted to meshes. Then we do establish the modeling parameters like how do we want to represent it? What is the simplification process that we are trying to follow? And then we develop the model. Okay, yeah. We have the drones, we have the scanner, we have the mesh. Then we turn them into objects. Then we create the BIM model. That's the idea. Okay, so it looks simple, but it's very difficult. It takes so much time. Sometimes, like for this column, you can spend like a week, maybe 2 weeks. It can take like, with a regular BIM model, you can do it like in a few hours. A model of this can take like a year or two. Okay, so it's not easy, but it is the results and the benefits are amazing. Okay, so this is why I'm telling you this is a great future direction for you. This means also money. Okay, I mean if you are putting a lot of time and effort into something, it means that you can charge more and you can get more money. Yeah, of course we have to do aligning, registration. This is all about like lect13 scanning and photogrammetry. We have Poisson surface reconstruction, triangulation, all kinds of different methods. I'm not going to go into that. But you basically create a mesh point, okay, out of that. And then you slice and extract profiles. Remember I was telling you, like Kemal Abi, he takes slices and then he creates the planes. What we do is we use the slices to create different, let's say, levels of planes, and we connect them and then we create the objects out of those several slices. That's what we are trying to achieve. Okay? There is this level of accuracy, okay? The concept, which we will not go into much detail, but level of accuracy, how much level of accuracy you want to achieve. Okay? Yeah. We map the parametric objects into the point cloud and figure out how much deviation we have. And then that deviation is also represented with colors. Okay? Like this is, you simplified the window, but this is the real window. And in between there is this like few centimeters deviation. I also show an example of that in the tutorial. Okay? So that's how it works. Of course, this is a very manual or semi-automated process. There's a lot of human intervention. This is why it's a very interesting beam field, okay? Because that person is not a drafts person. That person should understand historical construction systems, architectural orders, structural behavior, so that the model makes sense, okay? The model is something, the modeling process is an intellectual process. It's very difficult and it needs professional, let's say, to do that. It's not a draftsperson's work. Okay? Yeah, like you take this wall, like piece by piece, you basically define the wall. Okay, so it's as an individual, you use your expert knowledge to create this D model. Okay, so that's very important. So now, finally, once we have that data, how do we manage it? Okay, as I mentioned at the beginning, there is no one standard way of doing it. Okay, people are experimenting. They are paying computer engineers, computer scientists to design different interfaces, databases, resources. Yes.
Is there any IFC option?
Yes, I will talk about that. There is also IFC option. And we still rely on IFC for certain things. Especially, as you just said, if you're dealing with that interface, there should be a common language, and that is IFC in that case. Okay? Yeah, so we do level of details, graphic accuracy, level of geometry, level of information, LOE, okay? And we can have different LODs defined for different parts of the project. This is another thing, like when you think of a regular BIM project, LOD changes in time, right? But with the heritage, it's already there. The building is there, there is no time, right? But then you focus on object, like how much do I want to represent, in what detail do I want to represent this? In what detail do I need this, etc. So level of information need for each element needs to be established in that regard. So you can say that, well, this wall is very critical, very important, we have to focus on that. Then you can make it more detailed, okay? So, yeah. And in that case, you can even do something else, because when you have the data, you have the laser scan points, okay, point cloud. That point cloud is, let's say, 1 terabyte, okay? Then you put the 1 terabyte point cloud for that wall into, and that wall is very important for you, okay? Let's say you might say that 50 years later, I really want that point cloud, okay? Then you put that point cloud in a data repository, you simplify the wall like that, because you cannot put 1 terabyte into your BIM model, and then you put a link to that 1 terabyte data through that wall. Okay, you say that This is here, but if you want the highly detailed point cloud for that, you can reach it this way. Okay, so that's how it works. So level of history, this is another thing. So how much level of history that you make? Level of reliability, how reliable the history is. You can define that. Like, is it coming from a reliable source? Is it coming from, let's say, confirmed resources, etc.? So you can also define that. So archival sources in that regard needs to be vetted. Okay? And then you can say that, well, we don't know much about that. It is yellow. We know very well, green. We don't know anything hypothetical. It's red. So you can even color code your project in terms of the sources for history, okay, data. And of course, the 3D database is enriched semantically. How? We use documents, we use PDFs, we use historic photographs, material analysis, diagnostic reports, continuous monitoring of the situation, the temperature, humidity, cracks, vibrations, the number of people visiting, carbon dioxide levels, all kinds of things that you can feed in terms of data, and then you can basically feed them into the model. Okay? As a result, you can retrieve the stratigraphic history, material makeup, past maintenance records of the project, of the building from the past. Okay, so this model basically can be related to everything. That's the beauty of heritage grid. Okay, you can use that central database for everything. Okay, and of course, it is we can use IFC because we can talk to different professionals, structural engineers, conservators, and IFC format can be used for that database too. The nice thing about IFC format is that it's because it's an open format, it could be directly related to the database that is created by the software engineers. Okay, so let's say again open standard database that we can use for that. Okay, and it can be used for lifecycle management. This is another thing. We do restoration. We do let's say reconstruction, renewal of the building. But what's going to happen after 10 years? How are we going to find all what we have done? And how do we know what we have done was good or not? This is another thing, right? You make interventions, sometimes they are good for building, sometimes they're not. Sometimes you use the wrong material, sometimes you have chosen the wrong methodology. So what is it? So basically, you can go back in time, in time. Also, it's used for cultural dissemination, as I mentioned before. Virtual reality tours, augmented reality apps, interactive museum exhibits, like augmented reality. You can create a virtual reality or augmented reality, let's say, scene or exhibition. When someone enters the building, it immediately converts the building into its past state. Or when you walk through the antique town of, let's say, Ephesus, okay, city of Ephesus, if you put augmented reality, it immediately converts it into the, how it was in the past by putting the information, overlapping the information on existing ruins. Okay, so it can be done. And this way, if you present the history nicely in that regard, more attractively, more people can come and you can charge more money and you can also use that money for sustaining that facility. As long as you keep people away from, keep people in order. I mean, you don't really want people to be damaging, hurting the history, of course. Okay? Yeah. So one model, one digital model, you can do cultural dissemination, you can do precise asset and facility management, like we always do with. Okay? Let's summarize. So, heritage BIM is all about complex, irregular historic data. Complex, irregular. Crude buildings, old buildings, leaning walls, completely difficult. And then we turn them into structured parametric digital twins. Okay, so we create a digital twin of what is happening. And then we also use it as a multidisciplinary tool for long-term conservation. Okay, and Heritage BIM in that regard bridges the gap between raw reality captured data and also the semantic 3D databases. And basically, we need to find ways to overcome the software limitations. Like if you're using Revit, it's going to be difficult, so you have to find a way to overcome that. Okay, so that we have this dilemma of geometric accuracy or parametric behavior. How do we go in between these? Because we have to be careful about that. And then, of course, we need to look into level of history, level of reliability, transparent documents, transparently documented historic phases. Then we use IFC for standard representation. Okay, so this is how it works for future words, future, let's say, needs. Okay, good. I think this is it. Yeah. So we capture, we scan to BIM, then we basically manage it for the whole rest. All right. So I'll quickly show you one thing, and that is our Faculty of Architecture building also has a Heritage BIM model. It was done by İpek Hoca and her student. I think it was done in 2018. Let me see if I can find that. Sorry. I'm going to just remove this. Where is my thing? Yeah, here we go. Yeah. Metu Kim project. Okay, it's Metu Kim project, Keeping It Modern project. The project was managed by Professor Ayşen Savaş, and in that project they received a grant from Getty Foundation to document the Faculty of Architecture building. Our building is one of the 100 modern buildings in the world who received that grant. So in that regard, this building is very important. Okay, keep it in mind. It's beautiful. It's very important. And let me see, where do we have interact? Yeah, that's where we have it. So this is the models that they created. Okay. Let me see which one. I will go to this one. So by the way, here you have these barcodes. It takes you there with, like, you can use a virtual reality headset and directly jump into the building from here. Or you can use this one, like for instance, this is the one that is that we can now browse together. Okay, so done. Okay, now this is the building. What I can do is I can go first person, and then it's basically makes me jump. Yep, and then I can I can walk. If you are a computer gamer, probably it's going to be easy for you. I'm going to be using my mouse key. See, this is the BIM model they created of the faculty. Let me go through these walls. I'll show you something. Okay, let's jump. Yep. So this is Göbektaşı. So this is how, as I said, every team uses their own methods for representation of data. You see these balls or spheres, they call them, okay, the flying spheres. These spheres are there to connect us to the documentation, okay. Use Control key and click. Here it takes me to an external link, a Dropbox link. If I click View, what does it bring? Let's see. It brings me the data, okay, about the temperature changes. Or if I click on this one, open, let's see what it is. We see the drawings, original drawings of the space. See? Let's go back. Let's click on this one. Open. This shows me the reinforcement that they use some ground penetrating radar. What is it called, Eren? It's called ground penetrating radar. The radar that you used last summer for the reinforcement bars.
Was it
Georadar. Georadar. It's called georadar. Okay, so basically you scan the reinforced concrete wall, and it shows you where the reinforcements are, and then they make a drawing out of it. You see, and we have the drawing there. Or if I click on this one, it brings me to the measurements. And how about this one? They took some core drillings. Okay, this is like a core drill to figure out what's inside the concrete. Okay, let's look up there. There's two more. Yeah, this one. Sorry. This one is there's a crack there. If you go and look, there is a device there that's measuring the cracks, and it shows us how the crack has changed in time. Okay, and there's another one. Let me see. Yeah, and that one is again some measurement. Okay, so as you can see, but now these walls are now these doors, walls, windows. They are very idealized, very simplified, isn't it? Like when you compare. But the question is like, what is it critical? Like for this building, what should be the BIM model for this building like? So it's like that. Let me see. I think there was a door which we could. There was also information about that door. Let me see. I think it was the door at the basement here. Yeah. This is our studio where we are, but I think one of the objects, was it this one? No. One of the objects also was linked into some historic things. But yeah, you can go and play with it. There is another one. This is served at Autodesk 360. Okay. I still don't understand how it is still being served without being cancelled, but I don't know. This was done in 2018 or 19, I'm not sure. And there's this one. Continue. Let's see. This one is rendered. It's beautiful. Let's see if it works. Yeah, this was done by İpek Hoca and her student. What was his name? Şahin Akın. Yes, Şahin Akın did it. He's now living in Norway, I think, or Europe somewhere. Yeah, this one is fun too. So, as you can see, like they don't have, this project was of course limited. They don't have a database of objects. They only have some links to some Dropbox folders, okay? In reality, what we need is an interface that you can access all kinds of information, material, documents. You see, this one is texture. But here, the problem is that they have only one concrete texture that is repeating everywhere. So in that regard, it's not very realistic. I mean, it's very simplified, okay? But of course, the question is like, how should it be? Like, see, it's the same concrete texture as far as I know. It's being repeated. Yep.
Can
Orbit.
you see the early version of the Kubbe Alpha hocam?
With this one, no, I don't think they. What's going on? Yeah, I don't think they did that. I don't think they did that. Anyway, I'm not very good at. I'm underneath the floor. How can I zoom out? Yeah, here we go. Yeah, for instance, this is a very good suggestion. Like normal with BIM, with Heritage BIM, you should be able to see what the Kubbe Alpha was like originally. Okay, but now all we have is its current state. This is a good suggestion. Yeah, this is the current state of Kubbe Alpha, but this is not the origin. So you can basically bring it back to the historic, let's say, state. Can I turn around, move around? Yeah. It's very slow. No, yeah. I'm not very good at gaming. If it was my daughter, she would do it well. Sorry about that. Good. So, yeah, this is the website, Kim Project, Arch Method TR, and Interact. So this is for the general public. Okay? And it basically shows us what can be done with the Heritage BIM model. Okay? Good? Yeah. In the tutorial today, we talk about this process quickly, but I'm not expecting you to replicate it. Okay? It takes time and you need resources, so you don't need to go for that. But if you're interested, you can install Recap Photo, and you can take photos of your model, physical model, and then you can convert them. You have to download. You have to get it from Revit, Autodesk for free. Then you upload your photos to Recap Photo system, and then they upload to the server. Then they bring you back a digital model, a 3D model of your physical model. You can do that. It's fun. It's really good. But today's tutorial is all about creating drawings. So it's completely different. I want you to create two-dimensional drawings with annotation like measurements, dimensions, text, labels, annotations, and sheet, and put these onto these sheets, and also create a 1/20 detail, section detail, okay? I want you to work on it like I did. I'm giving you some examples. Complete it, and then create a PDF file out of that sheet. Okay, so that's the tutorial for today. Good. Any questions? No? Okay, let's stop there, and we'll be continuing after that.